Welcome back, folks. Let's dive in. This is the end of our integer series, so series D, our fourth video on dividing and exponents. And then we'll be done with integers. Let's dive in. Okay, a little division review real quick. If I had, say, 12 divided by 6, it could be written that way. It could also be written that way. Could also be written that way. Notice there's three ways you can do this, okay? These all mean the same thing. Some of you, I think, when you see this fraction bar, you kind of freak out a little bit. You think fractions, you maybe shut down. But I just want to point out that a fraction bar also means divide. And we divide the bottom into the top. So if we're looking at this problem, I just whacked my pen out. All right, so we're going to divide bottom into the top. So we're really just saying, how many times will 6 fit into 12? 6 will go into 12 twice, so there you go. This could be another way we see it. 12 divided by 6, and again, we're asking ourselves, how many times will that rear number, the right side, fit into that beginning number? How many groups of 6 fit into 12? Again, we know that's 2. And then this is the third way you can see division. And we're asking ourselves, yet again, how many times will 6 go into 12? Twice. We multiply 2 times 6. And if this was more than just one step, we could continue with the next number and keep dividing until we finish. All right, so that's the basics of division. Let's apply that to integers. My screen is unfreezing. There we go. What if we have something like this? Or another example. Okay, you guys learned last week how to apply these multiply divide rules with multiplication. So hopefully we can jump right to the answer. And you guys can see 3 goes into 18 6 times. That's just a division problem with a single negative, which goes to the answer. Number 2 is 2 negatives. That second problem, they both cancel. 24 divided by 6 is 4, and it's as simple as that. Notice that it's just like multiply. Single negatives go to the answer, pairs of negatives cancel. It's probably more the case that you guys might get confused about your division. Let's just show you one more. If you have something like, let's do, nope, that would not work out the way I want. Let's do something like that. This is kind of a mixture of a fraction problem and also a division problem. First of all, there's a single negative, so we know the answer is going to be negative. Second, we divide the 5 into the 18, and it won't go exactly. I'll write this up in the long division format. So we ask ourselves, how many groups of 5 will fit into 18? The answer is 3. When we take those 3 groups of 5 out of the 18, 3 times 5 is 15. We take them away from the 18. There's 3 left over as a remainder. So this 3 tells us there's 3 whole groups of 5 that we can divide into the 18, or we can take out of the fraction, however you want to look at it. This 3 tells us that we still have something left inside the fraction. There's still 3 units on top, and the 5 just carries over because that's what was on the bottom of the fraction to begin with. Okay, so that's another way to look at the problem. We're just rewriting a mixed number. An improper fraction is a mixed number. That single negative stays on the problem. Okay, that's pretty much it for division. It's just like multiplication. You guys practice these few right now. Copy these down, and once you have them, pause the video and work them out. That third one I just couldn't resist. I want you to practice a little bit of long division. Pause this, work those 3 out, and turn it back on in a minute. All right, here we go. Single negative goes to the answer, simple as that. 48 divided by 8, 6. Second one, pairs of negatives cancel. Notice that it's just like any other type of division problem. It's a negative, or excuse me, a fraction with 2 negatives. They cancel just like it's division. 32 over 8, 8 will go in 4 times. Last one, 24 into 127. We start by asking ourselves, will 24 fit into 12? Ignore the 7. And it won't. So therefore we have to move over. And we ask ourselves, how many groups of 24 will fit into 127? I'm going to guess 24 is about 25. And 25 goes into 104 times. So I'm going to guess about 5 times, and we'll see if we're right. That's how long division works. You just make your best guess and you multiply it out. 5 times 4 is 20. So now I'm multiplying to find out what exactly is 5 times 24. 5 times 2 is 10, plus 2 is 12. And I'm taking those 5 groups of 24 out of the 127. It's a 120. 7 is left over. So at this point, when you're in 4th grade, you'd see R7, and the teacher would say you're done. For us now, we go into the decimals. We'll add a decimal place, and we'll find out a partial value. And we ask ourselves the same thing. 24 into 70. I don't think it'll quite go 3 times, so I'm going to guess 2 times. 2 times 24, 48. Subtract that off. I can't actually write it out to finish, but it'll be 22. And we're just going to leave that 22. And we're going to say we've gone far enough that we can go at least 1 decimal place. That's reasonable precision for this problem. We know it's about 5.2 times that the 24 will fit into the 127. All right, that's division. Let's move on to integers. Once my screen unfreezes. So here we go. Did I say integers? Sorry, exponents. Quick exponent review before we look at how integers work with these guys. It's called the base. This guy up here is called your exponent. There's one major thing to watch for when you start working with these. Notice 3 to the 4th power, if I write that out to do the calculation, will look like this. The thing to notice, there is no 4 in the calculation. The 4 only comes in because that's how many of the base you multiply. Okay? That's the key to exponents. When kids have issues learning them, that's where they're usually tripping up. I'm only multiplying the base with other bases. Okay? The 4 just tells me how many 3's to multiply. And you can work this out by grouping these up. So I can go 3 times 3 is 9. Another 3 times 3 is 9. And now I know 9 times 9 is 81. Okay? That's what 3 to the 4th power is. That's just a basic review of exponents. So why don't you guys real quick practice some exponents. Pause the video, expand them like I did right here. You could use the practice. Expand them and then solve them. Pause the video, go. Okay, here we go. You should have paused. 3 of the base, 3 times 3 times 3 is 27. 2 to the 4th means there's 4 of that base 2. There is no 4 in the problem. And again, we can just work these out however makes the most sense to us. Group those 2's and multiply them to make 4. 4 times 4, we get 16. Last one, 5 times 5 times 5. There's 3 of them, but no 3 in the problem. Multiply them together, 125. Okay, there's a quick review of exponents. Let's apply that now with integers. Throw some negatives on here. Okay. If I write this out, we need to understand what that means. Now, it could mean that we know there's going to be 4 3's. The question is, am I going to multiply 4 negative 3's together, or does that negative come in later somehow? Okay? And here's the answer. It's inside of PEMDAS, which we will cover next week. Remember PEMDAS, you work down those letters, that acronym. That stands for parentheses, exponents, multiply and divide. Those guys go together. And then add and subtract, and those guys go together. Okay? Now, the important thing for us right now is that exponents is way up here at the top of the list, which means this exponent is a higher priority than your negative sign. That tells me that at the beginning of this problem, it's as if there's an invisible set of parentheses around the 3. The problem, in its order of operations order, says you need to take care of the exponent first, because technically a negative sign is attached to any number by multiplication. It's okay if that doesn't quite make sense to you right now. Unfortunately, with this online school faster pace of things, I may not always get to talk about things as much as I want. I'm sure some of you are happy about that, but negatives are attached through multiplication. So we automatically assume those invisible parentheses. And that means 3 times 3 times 3 times 3, I think we already did that problem, is 81. And after we finish, we then apply the negative, and we get negative 81. Okay? So let's show you one more example. If I have negative 6 squared, and I have the quantity negative 6 squared, and that's how you would say that. Okay, that's how somebody knows you've got parentheses around everything, the quantity of negative 6. How would we work this out? The second one is telling us, because there's parentheses, they're saying, I'm changing order of operations. I specifically want you to square the negative with the 6. That's why they put the parentheses in and put them outside of the negative. So when we expand this and write it out, they're telling us this. Use that negative on both of that base number when you multiply it out. And now it comes back to what we already know. Pairs of negatives cancel. We end up with positive 36. Let's compare that to the top version. Negative 6 squared without a parenthesis is actually telling us this. There's always an invisible parenthesis, and it's telling us take care of the exponent first, and then apply the negative at the end of the problem. And notice that results in 2 different answers, okay? So the 2 ways you might see exponents with integers is those 2 things, okay? No parentheses means exponent first, and otherwise they will tell you by putting parentheses around the problem to explicitly say, hey, I want you to square or cube or whatever all the negatives with it. Unless they tell you that, you don't. All right, you guys practice right here. Okay, I gave you 4 practice problems, and I made number 3 and 4 a little bit trickier. Don't worry, after you try them, I'm going to work them out for you. Pause it, try these 4, and I'll show you how to do them. All right, let's do it. First one here, no parentheses, which means there's an invisible set telling us to work through the exponent first. 4 times 4 times 4 is 64. And don't forget to apply your negative. There you go. Second one, because there are parentheses, we are going to square that negative with the number. Those 2 negatives are going to cancel. This stuff's easy for you guys. Challenge. Okay, number 3. Now the parentheses are there, but honestly, did I fool you? Because it's exactly the same as number 1. All I did was make the invisible parentheses visible. It's still telling you multiply the 4's together before the negatives applied, which we would already do anyway. So that's 64, and then bring in the negative. Okay? And last one. It might look tricky. I think you can do it. First of all, we've got parentheses saying cube, or take to the 3rd power everything inside. So we'll do that. The negative on the outside we'll just ignore for now. Okay, and in this case, multiple negatives, we just pair up those 2 and cancel. 1's left over, so 2 times 2 times 2 is 8. There was 1 negative left over. But wait, there was the original negative. And if we have 2 negatives still on the problem, what happens anytime you have a pair of negatives? That's right. They cancel. There you go. All right, now if you were a little confused on number 4, let's just check on this real quick. I think I put this in one of the lessons, but to be honest, I don't remember. Anytime there's more than 2 problems, more than 2 values you're multiplying, or more than 2 negatives in the problem, you're just going to count and pair them all up. There's a negative, there's a negative. It doesn't even matter which 2 you pick. That pair cancels. Okay? There's still a negative left in the problem by itself, which means it goes to the answer. So literally, we're just counting them up. All the even pairs you cancel out. If there's any single odd one left over, it goes to the answer. All right, guys. See you.